Okay, guys, I'm going to walk you through this dollar bill origami project that I want you to do. It should be pretty short. It should take you about 10 minutes. I'm going to post a document that shows you how to fold your dollar bill. I don't have a dollar. I have a 5 because I'm balling. You can use whatever you like. All right, so the first step, you're going to fold it in half this way. Sorry about the shadows. My home setup is not ideal, but it is what it is. Okay, so you're going to fold it in half this way, open it back up. Then you're going to take the top right corner, and you want to, that crease that you just made, you're going to take that top right corner and you're going to fold it down exactly on that crease, okay, as best you can. And right in this corner, you'll see that it comes to a nice point right there. So once you have that lined up, go ahead and crease that firmly. You do the exact same thing on the other side. So take that corner to that halfway crease that you had before. Make sure that corner is nice and crisp right there. Fold it down. Okay, so now you have this shape. The next thing you're going to do is you're going to take this bottom right corner and match it up to that top left corner. So when you do that, kind of goes like that. Okay, so when you get that all set up, make that nice and crisp. Right here you have a rhombus. Okay, if you look at the outer edge, this forms a rhombus. We'll come back to this in a few minutes. The next thing you want to do is take this corner and bring it up to match this corner. So it kind of just folds the whole thing in half. And this shape that you are left with is an equilateral triangle. So remember what you know about equilateral triangles? All three side lengths are the same. And don't you know the measure of each of the three angles? So that's going to come into play in a little bit too. That'll be important. Okay, so the next thing they have you do is kind of open this shape up to form a three-dimensional shape called a tetrahedron. So if you unfold it a little bit, so watch what I'm doing. So I'm just unfolding, unfold, and then these two little smaller triangles, kind of unfold them a little bit, and then they come together just like that. And now you have this three-dimensional shape where each face, it's called, or each side, is an equilateral triangle, right? So do you see that? You've got 4 of them. And one of them is made up of these 2 triangles side by side. Okay, so those 2 triangles are going to be congruent to each other. They're also, I'm going to turn around this way, they're not only congruent to each other, they are right triangles. So you have, if you look at just one of those, if you look at just one of them, down here in the corner is going to be a right angle. And remember, since we said that each of these bigger triangles were equilateral triangles, doesn't that mean you know what this angle is right here? It's 60. So that means that these 2 triangles are not only right triangles, they are 30, 60, 90 right triangles. Okay? So then the next thing that you're going to be asked to find is the area of one of these triangles, one of the faces of this tetrahedron, okay? So any one of these, because they're all the same. So again, I would stick with this side though that has the triangle split into 2. Why? Because think about what the area of a triangle is. It's 1/2 the base times the height. So if I were looking at one of these, I don't necessarily know what the height is. I don't know what the base is on this one either. But if you look at this one, if you read the worksheet that has the questions on it, the very first thing they say up at the top is that the short side of a dollar bill or a, whatever US currency you're using, the short side of a bill is 6 centimeters long. So if you unfold this a little bit, look right here. So that's the short side, that's 6 centimeters. So watch that same side. As I fold this back together, look where that is. That is the height of one of these triangles. How cool! So now you have the height of this triangle. It's 6 centimeters. So to find the area of this whole entire triangle, right, the whole big one, you need 1/2 the base times the height. You have the height, all you need is the base. So how are you going to find the base? Because it's, this here. Well, remember, these 2 triangles are the same. So once you find the base of this little piece, you can just double it. Well, guys, remember that it's a 30, 60, 90 right triangle. So if you have one side of a 30, 60, 90, you should be able to get this side using the stuff that we talked about in the right triangles section, okay? One thing I do want to caution you on is that all of your answers should be in radical form. We're not going to have any decimals. So make sure that you are taking this side length, and when you go to find the base that you do it appropriately. And then they're going to ask you for a bunch of other questions, other things. So let me just take a glance. So yeah, the first thing you have to do is find the area of one of the triangles. So we just went over that, 1/2 base times height. Then in number 2, they want the surface area of the tetrahedron. So to find surface area of any shape, you just find the area of each of its faces and add them all together. Well, since each face is just one of these equilateral triangles, you're just going to take the area of one triangle that you found in number 1, and couldn't you just multiply it by 4 because you have 4 of these identical triangles that make up this tetrahedron? Okay, so that's all you have to do for number 2. Just take your answer for number 1 and multiply it by 4. 3 asks, why is the surface area of the tetrahedron also the area of the whole dollar bill? So my hint to you on that is, check this out. If you found the area of each one of these faces and added them together, well, by George, doesn't it get you, bam, the whole thing, right? So that's pretty much the answer. All right, 4 says you create a rhombus. What's the exact area of the rhombus? So if I just jump back to that rhombus shape, I think it was right here. Well, what is that rhombus made up of? Isn't it just 2 of these equilateral triangles? So again, if you have the answer to number 1, you can get this answer as well. And 5 asks you, when you were here and you had this isosceles trapezoid, what is the area of this isosceles trapezoid? Honestly, the easiest way to find that is by looking at it flipped over. There is a formula for area of an isosceles or any trapezoid, but you don't even need it, because look at what this trapezoid is made up of. Look, the lighting is actually really helpful here because you can see what it's made up of. Look, whoops. Okay, so that's my big hint for that one. And the last one, all you have to do is find out what the length of the long side of the bill is. So if I open it all the way back up, you knew from the beginning that this was 6 centimeters. Now they want you to find this length. But again, that should be relatively easy to find if you kind of take a look at trying to get the shadows just right. What makes up this whole bottom? Look at it, guys. Don't you see? You know this length, and then you know this length. They're the same. Just add them together. And you should have that. Okay? I hope this helps.